Okay, we're ready for section 4.2, solving problems with fractions and unknowns, multiplication and division. The last chapter that we did were solving problems with fractions, but we were mainly using addition and subtraction, which remember, you use addition and subtraction with fractions, then you always have to have common denominators. But the thing with multiplication and division in fractions is you don't have to. So it makes it a little easier. All right, so let's go ahead and read this. Let's say that someone gets a bonus of 1/20th of his monthly salary. If the amount of the bonus was $60, what was the amount of his salary? So you're going to use X to represent the monthly salary. So you could represent the problem like this. So 1/20th of the salary, remember of is times, of the salary, which we don't know, so that's X, equals $60. And you're just going to work the problem. So in other words, you want to find the number that if you take 1/20th of it gives you $60. So how do you do this? Well, the same way you would if you were working with integers, by performing the same operation when using the same quantity. So right here, this is times. So the opposite of times is division. So you're going to divide. Now, fraction doesn't change how you solve it. You do the same thing. So you're going to take this. This is our equation. You're going to divide both sides by 1/20th. So remember, the fraction line is division. So 1/20th divided by 1/20th on both sides. Okay? The fraction line represents division. So you'll complete the division by inverting. Remember, when you divide, you invert and change it to multiplication. So here we go. It's 1/20th times 20 over 1. That cancels everything out. So you're left with 1x, which you only say x, equals, and then when you do the calculations over here, this would be 60 over 1. So 60 times 20 then would be 1200. So substitute that 1200 for x in the original equation. So 1/20th of 1200 equals $60. And that is true. Once again, the same principles we've been using with integers and decimals apply to fractions as well. You just have to couple them with the things that you already know about fractions. This holds true with multiplication too. You can multiply both sides by the same fraction without changing the problem. So let's look at this example. Pardon me. Okay, so x divided by 4 4/5 pounds equals 5. Here's an example. Say we divide apples into 4 4/5 pound packages. It's hard to say. And end up with 5 packages. How many apples did we have to start with? All right, so here's your setup. Well, this is your setup. So basically, you'll want to change this mixed number into an improper fraction. Remember, you do that by saying 5 times 4 plus 4, which gives you 24/5. Just you always want to make sure and remember that when you're working with division and multiplication and mixed numbers, you'll want to change those into improper. It makes it easier to work with. Now what you're going to do is you're going to multiply, because this is division. So to undo this and get x by itself, we need to multiply both sides by 24/5. So that's what they did here, which canceled the 24/5 pounds out. So you're left with x by itself, equals, and this would be 5 over 1. The 5s cancel each other out, so you're left with 24 over 1, which is the same as 24 pounds. Now, this is where it gets a little bit more in-depth, I think. Back in book 1, we learned how to find the volume of several different three-dimensional objects, like prism and cylinder. Now, it's time to learn how to find the volume of another three-dimensional solid, the pyramid. The formula to find the volume of a pyramid includes, you guessed it, a fraction. So first though, what's a pyramid? A pyramid is the name of a three-dimensional solid whose base is a polygon, but whose sides are triangles that come up to a point. While when we think of pyramids, most of us think of the Egyptian pyramids that have square bases. Pyramids can have any polygon as a base. See these different bases? This is a triangular base, this is a square base, and this is however many sides those are base. So a solid whose base is a polygon and whose sides are triangles that come to a point, that's a pyramid. Now, because of the way the sides of the pyramid come to one central point, a pyramid's volume always equals 1/3 the volume it would if it were a prism. We can express this relationship in this formula. This right here. The volume of a pyramid equals 1/3 times the area of the base times the height. Notice the fraction along with the letters, the variables, letters used as placeholders. So now, if you know this relationship, you can find the volume of any pyramid. Now, here is an example. The volume of a pyramid whose base is 40 square feet and whose height is 20. Just fill in your numbers. Okay, so here you have volume is 1/3 times your base is 40 square feet times 20 feet. Okay, so when you multiply 40 times 20 times 1/3, you get cubed feet because you have this 2 and this 1, which makes 3, which is right because when you do volume, you get cubic feet. And then you do all your multiplication. Now, I want to show you something. I want you to notice this uppercase B and this lowercase h. You might have wondered that. Okay. So, the capital letters B and V are used for base and volume. You could have used a lowercase b and v, or any other letter or symbol for that matter, but since we typically use a lowercase b to mean the length of the bottom, like just the base of a triangle or parallelogram, we use a capital B to differentiate that we're meaning the entire area of the polygon that forms the base of the pyramid. Similarly, since scientists typically use a lowercase v to stand for velocity, which is speed in a specific direction, to aid in differentiating between the two, we used an uppercase V for volume. So the important thing is just to remember that however it's written, the formula for volume represents the relationship between the volume, the area of the base, and the height of the pyramid. Now, once again, we're using these same principles. So on worksheet 4.2, we'll have a chance to practice both the skill, applying the skill to find the volume of some actual pyramids. So let's look at worksheet 4.2. Now, on the front part, I think it's going to be pretty easy for you. 1, A, B, and C. These are just your formulas with an example meaning. And you're just going to do like this one, you'll have to divide both sides by 2/3. Same thing here. This one, you'll multiply both sides. You'll have to change this to a mixed number and then multiply those sides. So these three, A, B, and C, are exactly what we did in the example. So you might want to go back and look if you can't do it. So on number 2, A and B, you're given a problem. And then on this one, they tell you the actual equation. So you just work that equation, okay? But it's multiplication, so remember, you just multiply across and then simplify. All right? Now this, they give you the problem, but you need to write the formula. Not the formula, the equation. Very easy. Just think about what you're looking for and give it a variable, X or N or A or B or whatever you want to give it. And just put it where it goes. And then once you have your equation written out, you should be able to solve it. Make sure you always label it as to what it needs to be. Now, on this side, it said these are some actual dimensions from the Tour Egypt website regarding pyramids in Egypt. Use the information given to find the requested information. Round your answers to the nearest whole number. So on both of these, you need whole number answers. Okay, you'll have to round it. Now, remember the formula for this. It's V for volume equals 1/3 times the area of the base times the height. I believe that's right, right? Oh, I have it right in front of me. 1/3 base times height. That's right. Okay. This is uppercase B because it's the area of the base. Now, on this one, you're just going to plug your numbers in and do the calculations. Now, on this one, I wanted to do a little explaining to you. The volume of the main pyramid in the pyramid complex of Uzurkov, the original height was 163 feet and the base is a square with 240.5 feet sides. Hint, this time you're not given the area of the base, so you'll have to find it knowing what you know about finding the area of a square. So basically this one right here is going to have 2 steps, but you can combine them into one. You're going to find the volume of the pyramid, which is this. But when it comes to this right here, this part, you're not given the area of the base. They tell you what shape it is and the sides. It is a square, and remember a square, all 4 sides are the same. Each side is 240.5 feet. Okay, so to find the area of that square base, you would do 240.5 times 240.5. You have to multiply that to get the area of that, and then that number will be this number, if that makes sense. Now you can work that in there. In fact, let me kind of show you how you would write this out. You may already know. I hope you do. Now, times, the next one is the area of the base, which we're going to figure out. So we're going to put this in parentheses because the area of the base is 240.5 times 240.5. That'll give you the B. And then times the height was 163 feet. This will kind of be how you work this one out. See how I told you you can work it in there to it? So that's what we've done. Okay, so that's how you'll figure that one out. Okay, so I think these unknowns, these should be pretty level. This comes back from a lesson just previously that we've been working on. This should be pretty easy. This one will be based on a formula. So you'll write the formula itself, plug in your numbers, and figure out what it is. Okay? So it should be pretty easy. If you need any help on this page, let me know. Not going to grade it, but I do want to see how well you do on it. But if you're having any trouble, let me know because I don't want to move forward until we are sure of what we're doing. Okay? All right. That's all for today.
Yes!